Okay, so we want to lay out what a common base amplifier looks like. So if we go over to our little equation sheet, you can see that this is our common base configuration right here. So if we grab this one and we'll bring it over. Okay, so what we have to do here is we have to bias our transistor to get it to work with that V base. So what we see here is we're going to start with our RC like that has. Here is our transistor. And then we're going to come over here and we're going to do resistor divider biasing like we've done before. And so if this is our RC, this is our R1, and this is our R2. Now this one kind of shows that I have an RE right here, and then I put an input voltage right here. Now usually with our input voltages, we really don't want this to be the DC bias on this to mess everything up. So what have we usually been doing? We've been coming in here and using a coupling capacitor right there. Okay, now when we do this, if I do the DC biasing, we used the capacitor became an open circuit. So this would look like this. And I guess officially we have a resistor here, but it doesn't really matter because this is just dangling open. So there's no current path through and there's no current flow. So in this case, our IE would be equal to 0. So you can kind of see that this is not allowed because then it won't bias it. So the options are either we have to come in here and not do this, so we would have to go like that. But then if there gets some DC bias on my VN, it's going to mess everything up. So what we want to do is we want to come up with a different configuration where we can put that coupling capacitor in. So we're going to start with the basic configuration that we've seen over and over, which is our biased amplifier, or our biased BJT. Okay, and then this is our output like it showed on there. But then we don't want to break this ground, so what we're going to do is we're going to come over here and add our input in at this point. So therefore, if it's an AC analysis, we get this. Okay, and if it's a DC analysis, we just get this. So then everything works fine. Okay, so let's go back to our configuration here. And if I have a source resistance, that's going to go over here where my input is. Now the other thing is sometimes we're only using these resistors for biasing. So sometimes we'll come in here and put a capacitor right there. And if I put a capacitor right there, then if I go back over here and look, then this RB right here is going to go to 0 so that I can get rid of this RB right there. Okay. Now also in this configuration, when I look in here, we're not connected, or I guess I can go back here. We're not connected here. You see, we're going to ground this and connect our V in right there, which means that when I'm actually doing my AC analysis, as far as the gain goes, the RE goes to 0. So with this configuration, you see if I grab this equation here, that this equation is effectively going to be RE is equal to 0 because it gets shorted out by the capacitor. So then we get AV is equal to GMRC, which is exactly the same equation as our common emitter amplifier, except for the fact that it is non-inverting. So this is what the basic configuration looks like. So I got our basic biasing that we had before. We connect our input in through a capacitor directly to our emitter terminal, and then our output is just connected to our collector.